Okay, so we're back with this 25mm plate, and let's see if we can find a crack-like indication in this as well. Now, you'll see that this echo is here. I cannot fully maximize it because the cap is in the way. If you cannot fully maximize an echo, you cannot accurately plot what there is. But judging by the beam path being 38.4, this being a 45-degree probe, and the thickness being 25 mils, that should be the root of the weld. So if we pull back from the root, you'll notice that we get this. Now I want you to have a look specifically at what this echo looks like. It's quite broad, it's got a lot of facets, it's very high. Remember, a DAC decreases the sound the deeper it goes in. So this is actually a very, very high response that we're getting here. And you can see it's a broad, ugly echo. It's not a clear, simple echo. I'm actually going to have to decrease my decibels to maximize this. But when I find it, and I maximize it, we'll see about 72 millimeters of beam, and it's about 70 mils from the center. So 70 millimeters from where my sound exits my probe to the center of the weld. On this side, I can see that very same ugly echo coming up after skip. I'll maximize it, so get the maximum out of it. Ooh, I'm going to need to decrease even more decibels. This is a very big response. This is about 72 millimeters as well of beam. And the distance from center though is a lot less. From center to where the sound exits my probe is 35 millimeters. And remember, this that we're using is a 45-degree probe from each side, and it's got a big response. Let's see how it plots out. Alright, I've transferred the data to my drawing, and we use the 45 degrees on both sides. Once again, this is a scale drawing of my weld if we were to cut a slice out of it. So I'm just going to draw in a 70 millimeter surface distance. So that's about 70 millimeters from the surface. And at 45 degrees, I'm going to draw in a 72 millimeter beam. So let's first measure where 45 degrees are. And then drawing the sound. So that's about 35 millimeters down to the bottom. Now, if we have 72 and we minus 35, we should be left with about 37. So once again, let's draw in our line at 45 degrees. So it looks like to be right about here. It might bounce a little 2 millimeters from the top here. Let's see what we can do on the other side. So on the other side, we've got a 35 mil surface distance, and we draw in at 45 degrees. Looks like I measured this one a little bit wrong. This isn't, it's about 37, it's not 35. So if you have 37, you should be left with 35. So this should come up just below the surface there. And this one is 37. as well. Let me just make sure. Yeah, it seems I measured the first one a little bit incorrectly. No worries, that happens. You can correct it, you can have a look. Okay, 45 degrees from here. And we're drawing it up. So if it's 72 minus 37, we should have 35 left. So, if we have our weld, it seems to plot out in this area over here. Now, typically, if something plots out in this area and it has an echo that's ugly and sharp, like the echo we saw. In fact, I think the echo we saw was a little bit at the beginning, then a big one, then a little bit, then another big one, and maybe a little bit here at the end as well. It was high level as well. Given the area where this indication plots out and the characteristic of this echo, this would likely be a toe crack. Cracks have echoes that look nasty, they're quite high level, and we know from our theory that this area is